So we've been talking a lot about forces, and this is going to lead us into our next topic, which is going to be simple machines. Now, simple machines are always there to help us, right? So if something's too heavy, they'll reduce the force to be able to, for example, lift something. Okay, but they always come at a price. And we're going to talk about the different examples. I have some here, and we're going to talk about each different example. Right, so I mean, simple machines have been used, well, they're used in modern times, but they've also been used a very, very, very long time. I mean, if you go to a museum and you look at a sphere, right, at the end is what we call a wedge. Right? And a wedge is simply two inclined planes. So inclined planes are used a lot too. Right? I mean, look at this simple machine. Right? If you're building the pyramids, for example, right, you're going to have a type of ball bearing to reduce friction and an inclined plane. Well, how does an inclined plane help? Well, we use them on trucks today. Right? You can push things up an inclined plane instead of having to lift it straight up. It's a lot easier. Okay, so inclined planes help us. Things like pulleys. Pulleys will help us in this case, right? In this case where we have one pulley, right? If we want to lift something up, we pull down. It's a lot easier to pull something down because you can literally put your weight into it and let your own weight pull something down. Right? But by pulling down, a pulley changes the direction of the force and pulls up whatever it is you have attached to it. Right? We'll talk more about pulleys later, but if you also have multiple pulleys, you can actually change the amount of force that's required as well. Right? Levers are also very helpful. Right? If you have a lever or a lever, however you want to pronounce it, both ways are fine. Right? You can lift something up a lot easier as well. I am sure you can imagine, say, a wheelbarrow. Right? That's a lever, and you'll put a whole bunch of weight inside the wheelbarrow, and you'll lift it up at one end. And we'll go over more examples of each of these later. Okay, so any simple machine is just one that helps us perform tasks, right? And therefore must have one of these 5 main functions, at least one. One is to change energy from one form to another. For example, this is a hydroelectric generator where water flows, right, and changes that energy of flowing water into electrical energy. That's one example. Okay? And these 5 functions for a machine are right on your handout too. So I'll come back to them and we'll summarize later. One is to transfer forces. So a car's transmission transfers force, right, from the motor to the wheels. Okay? We talked about this one. Change the direction of force. So a pulley will change the direction of force. Right? If you wanted to raise a flag up to the top of a pole, it's very inconvenient if you had to actually first climb to the top and pull up. Right? Instead, a pulley will let us stay at the bottom of the pole, pull down in order to raise the flag up. Number 4, change the magnitude of the force. So in a lot of cases, something is very, very heavy. I mean, if you had to try and lift the piano, that would be heavy. You're probably not going to be able to do it on your own. But if you have multiple pulleys, like this one here, right, it'll actually reduce the amount of force needed to lift it up. Of course, that comes at a price, and we'll talk about what that price is later. And I don't just mean like the money required to buy the pulleys. Right? Next, change the distance or speed. So we're actually going to create a little mini bicycle setup today in our lab. Right? But I'm sure you've all looked at a bicycle at least, and you've seen that you have gears of different sizes attached with a chain. Right? Now you can either have it on a high gear, which requires a lot of force, but that higher force will cause the wheels to spin faster. Of course, if you're going uphill, you might want a lower gear because it requires less force. But the price to be able to pedal up easier is that you don't have as much speed. So you're exchanging force for speed. Okay. Now, if you have one simple machine, well, let's just call it simple machine. But if you have more than one simple machine, that's called a complex machine. Right? And usually all simple machines we break into two families that share characteristics. We have the lever family and the inclined plane family. Okay, today we're going to primarily talk about the inclined plane family, but first let's go over an example. Alright, so like I said on our handout, here we have the five functions, just summarize for you. Change energy, transfer forces, change direction of force, change magnitude of force, or change the distance or speed. So we're going to look at some examples in question 1. We're going to say which function, or the main function, there could be more than one, do each of the following. So an axe. Now an axe is actually an inclined plane. Right? We call it a wedge, right? But really if you have one inclined plane attached to another inclined plane, that's simply two inclined planes. And two inclined planes we just call a wedge. Okay, so what does a wedge do? Right? It actually, I'm just going to write the numbers, does number 3, which changes the direction of force. How does it change the direction of force? Well, as it penetrates something, you're pushing inwards, so you're cutting a tree, right? You're slicing sideways, but then it starts putting a force like this to actually separate the tree. Right? So it's changing the direction of the force, for one, right? But you can also say it changes the magnitude of the force. So you putting a small force, or well, a relatively small force on the tree, the wedge will actually increase that. Right? But over a larger distance. Right? Now a tennis racket. What kind of simple machine is a tennis racket? Well, it's a lever, right? Just with any sport, a golf club, right? Anything that's sort of extending really the length of your arm, right, is going to cause a larger force. Right? So in this case, it is changing the magnitude of force, because I just said a longer arm increases the force. Right? You can imagine, for example, trying to open a door. Right? Now a door has hinges about which the door will rotate. Right? Now if you push close to those hinges, technically the length of the arm, or the distance from where you're pushing to where the hinges are, is very short. And it's really hard to push that door open. But if you push at the very far end of the door, the opposite side of the hinges, right, you have a very, very large arm, which causes a much, much greater force, and that door opens really easily. So it's the same with a tennis racket. You're increasing the length of the arm, therefore increasing the force. Okay, so you might want to say, I sometimes have students say, well, why don't we just make tennis rackets that are like 2 meters long? It's like, well, it'd be very difficult to control a tennis racket that long, for one thing. Okay. A doorknob. Okay. A doorknob, you can think as sort of like a wheel and axle. Right? So if you take apart a doorknob, it's sort of got a small axle in there, or that rotates. Right? It's like a cylinder. Right? But the part you grab is actually quite large. Right? It's almost like taking a wrench to a screw. The screw is quite small, but you're increasing the size of the head by using the length of the wrench. Okay, so we call that a wheel and axle. Even though a wrench you could also call a lever. Okay? And it's going to, one, change the direction of force. Okay? Because it can sort of cause the force to be applied on the lock to move it in or out. And it can also change the magnitude of the force. Lastly, a screwdriver. Well, again, I spelled screwdriver wrong. Screwdiver. Put an R in there. Okay, well, a screwdriver, if you look at the end, it sort of looks similar to this. So it does look like a wedge. Right? But I just want to talk about an actual screw for a second here, not the screwdriver. Screw sort of looks like this. Right? And what it actually is an inclined plane. Imagine looking at a mountain, right? And there's a long road going down the mountain. That's an inclined plane. Or you can take that same road, and instead of going straight down the mountain, you can wrap it around the mountain. Right? That's what a screw is. Right? It's that inclined plane that's being wrapped around. Right? So you can slowly apply a large force over a greater distance as you twist the screw into whatever object you're pushing it into. Right? And we'll go into more detail for a lot of these later. Right? But that's obviously going to change the magnitude of the force. Right? And your screwdriver, same thing. It's changing the magnitude of the force, because you'll notice the handle is a lot thicker than the actual the end of the screwdriver. Because it's thicker, it's similar to our doorknob example, right? Or pushing the door example. You're increasing the length of the radius or the arm of which you apply your force to where the actual rotation occurs. Okay? Let me just pause there. Alright, so here's our inclined plane. Okay, it's simply a ramp where any load that's put on it, right, can be moved by some force up the ramp. And the force required to move it up the ramp is less than the force that would be required to simply lift it straight up. Right? You can imagine walking upstairs compared to climbing up a ladder. Right? Or if you wanted to lift something, let's say you had a heavy box, right? You'd probably prefer to carry it upstairs as opposed to, or even pushing it up a ramp, as opposed to carrying it up a ladder. And if we take two inclined planes together, that's called a wedge. And I've already mentioned these, but you take an inclined plane and you wrap it around some sort of central cylinder. That's called a screw. Now the interesting thing with screws is if you look at each each screw, right there, it's also a wedge. Right? Here, these are all wedges as well as, so technically you've got three inclined planes, two for the wedge and one for the wrapping around it. Okay, so I think I mentioned a compound machine would simply be multiple simple machines put together, like this jack here, or like a bicycle, which we'll do in our lab today. So what we're going to do is we are going to go over the next question on the handout, which simply says, which simple machines forms the basis of both? All right, so a doorstop, right? If you put a doorstop in the bottom of your door, it looks like this, right? Now that I've drawn it for you, I think it's easy to tell, well, a doorstop is an inclined plane. Okay, an escalator, same thing, inclined plane. A mountain highway, well, if it just goes straight up the highway, that's an inclined plane again, right? But it can also be a screw if it wraps around the mountain. But remember, a screw is also simply an inclined plane. Same with a pencil sharpener. Pencil sharpener, the blade is an inclined plane, and you're also sort of screwing it in, so it's an inclined plane. So all these examples are inclined plane, and that's what we're going to talk about the most today. And we're also going to watch a good animation video that goes over what an inclined plane is and how it can be used. All right, so any questions?